Good afternoon, this is Joshua Hazlewood presenting his video, The Mousetrap Car. For a little introduction, the objective of this project was to build a mousetrap car with a standard mousetrap as a propulsion system. I needed to make this car travel 10 feet and travel as straight as a path as possible. The mousetrap car is really a common project for many physics classes and had an infinite many ways to being built, but I needed to focus on building a car that traveled straight and traveled 10 feet. So that task proved much harder than originally planned. The design phase started with two different designs. The first design was a simple back axle double wheels attached to a string with a lever arm attached to the mousetrap, which would act as a propulsion system, and then up front just a single wheel. I thought that the single wheel would keep the weight of the car down, distance would be achieved better, and really just the accuracy and the stability of the first design was kind of up in the air until built and proven wrong. Second design was a double wheel up front. I figured comparing these two models would help me get to the final phase. So having 2 or 4 wheels total, all made of DVDs, that would help with variations and finding the perfect final design. So this model 1 was built with the single front wheel. As you can see, structurally does not look sound and was proven not sound, as that frame is cardboard with tape added for structural purposes. And then we used actually straws that we had at the house, and I used those to act as the bushings for that front axle. Second model was better structurally sound. Went to a popsicle design, which actually kept for the final design, and had those 2 DVD front wheels implemented there. The materials for Model 1 were DVDs for the wheels, bushings were pin tubes, axles were made of the wooden dowels, anchoring points were the round hooks, and the frame was made of cardboard. The second model went to popsicle sticks as the frame, and really overall kept the same kind of design, used bushings for pin tubes, axles as the wooden dowels, and went to the 2 front DVDs, or front DVD wheels. There's the prices. Let me make sure that shows up. So there's the prices as far as materials purchased. We were kept right at that $30 mark. I got lucky with having most of the tools and supplies used to build actually at my house, which helped. So the testing and trials of the first model. This model was really the only one we needed for test or for speed results, as far as knowing where the string needed to be attached, how that lever arm needed to be moved and attached, which we later changed. That lever arm was not proven sturdy, so we actually added wire in there, which helps stable that lever arm. And then here you can see some graphs. So ran distance over accuracy, and really what we were looking for is the tightest data points possible on these MATLAB graphs. As you can see, the first model actually didn't prove to be as distance achieving as the final model and the Model 2, and accuracy was kind of everywhere. I'll bring you in to show that. As you can see, accuracy there, this graph at the bottom, this is the 10-inch to the right, the negative numbers are inches to the left, and this distance on the y-axis is all in feet. So we were achieving a good distance, but inches and accuracy were off. And for Model 2, Where I was having to run this car was in my kitchen, so 15 feet was actually the max between me and the wall, so it was hitting the wall every time, which is good, so we could achieve a distance. But that, go back, and I don't know how well that green is showing up. We achieved 15, but that accuracy was still a little off to the left and to the right as well. So we needed to figure out a design change to improve that. Design improvements. We went single DVD wheel to 2 DVD wheels. The cardboard frame moved to the popsicle frame, and then that cruddy axle design was really just the straws and the pin tubes. We went to a better axle design of the dowels and the pin tubes, which proved far better for accuracy and stability. There's a couple main designs for getting to the final design. Again, we wired that lever arm to the Mousetrap. Went to these coffee cup lid or coffee cup bottoms for the front wheels. And that was also attached to the wooden dial inside these pin tubes. The smaller diameter there really helped as far as weight and also just stability with a wider axle. And then here's that back wheel design. So the decisions made for the final design, the wheels were changed on the front, like I said, to the coffee cup bottoms. This added a smaller diameter up there. It was easier to get a straighter path. And it was a better overall front axle design for the car. And then the wider wheel axle, that also allowed that better stability, like I said. So here's that final design. The stopper was implemented in the front of the car just to keep the 1 by 1 dimensions. So the car is actually never more than a foot, or it's never more than a foot high. It stayed actually, I think, all straight up. It's about 9 or 10 inches, and then it never surpasses the width of the car, which stays under a foot. Summary: the final car proved a structurally more sound car. It also had perks of wider wheelbase, which added accuracy down the path. The biggest obstacle, of course, was getting distance and accuracy. So distance was achieved by adding the tape, which gave that friction for the wheels to spin, and also adding tape to the axle where the string was attached to. That was something we found in the first design, and that we kept throughout all of our designs, which really kept the tension on the string. It didn't snap the Mousetrap forward real quick, spinning out the tires, and gave us that overall distance. Accuracy was achieved by the wider axle and smaller diameter wheels up front for that final design. That gave us the better accuracy we needed and overall structural stability of the car. And here's my appendix with these codes that were formed to generate the graphs. There's my personal photo. It's me looking pretty happy. There's the data graph for the final design. And here's the dimension pictures. As you can see, this never surpassed a foot in any of these dimensions taken. And here's my safety diplomas for both, or all 4 of the classes. And that is all. In the next videos, you will see the car running and in achieving that distance.